Imagine waking up to a sudden, deafening roar that shakes your very foundations. Your city is buried under a thick layer of ash and rock, its once familiar streets now unrecognizable. The sound of screams and wails echoes through the desolate landscape as panic sets in. Volcanic eruptions have been reshaping our planet for millions of years. They're awe-inspiring displays of nature's fury that can level cities, change climates, and even impact global economies. From ancient civilizations to modern-day catastrophes, volcanoes have left an indelible mark on human history. To understand the significance of these events, let's take a step back and examine the science behind volcanic eruptions. Volcanoes are essential events through which magma from deep within the earth rises to the surface. When this molten rock is released, it can create explosive blasts that scatter ash and debris far and wide. The severity of an eruption depends on factors like the type of volcano, the pressure built up in the magma chamber, and the explosivity of the event. Now, let's delve into some of the deadliest volcanic eruptions in history, those that destroyed entire cities and changed the climate. One such catastrophe is the 79 CE eruption of Mount Vesuvius. The once thriving Roman city of Pompeii was caught off guard as a massive pyroclastic flow swept through its streets, burying everything in its path. Archaeologists later discovered the remarkably preserved ruins, providing a chilling glimpse into the lives of those who perished. Pyroclastic flows are fast-moving currents of hot ash, gas, and rock that can reach speeds of up to 100 mph. They're responsible for most volcanic-related deaths, and their impact is often devastating due to the sheer velocity at which they move. Imagine being caught in a maelstrom of scorching heat, suffocating fumes, and jagged debris. It's no wonder that pyroclastic flows have become synonymous with volcanic horror. One of the most catastrophic eruptions in recent history is the 1985 Nevado del Ruiz eruption in Colombia. The volcano's snow-capped peak had been quiet for decades, but on December 15, a massive landslide triggered a devastating avalanche that swept through the nearby town of Armero. Over 23,000 people lost their lives, as the icy torrent destroyed everything in its path. This disaster raises questions about our preparedness and ability to mitigate volcanic risks. With growing urbanization and increased reliance on technology, we've become accustomed to living in areas vulnerable to natural disasters. However, recent events have shown that even the most advanced warning systems can be insufficient when it comes to predicting the unpredictable nature of volcanoes. Another example of a city-changing eruption is the 1815 Mount Tambora event in Indonesia. The massive explosion was so powerful that it altered global climate patterns, leading to what became known as the year without a summer in 1816. Global temperatures plummeted due to the massive amounts of sulfur dioxide released into the atmosphere, causing widespread crop failures and famine. The effects of such an eruption are far-reaching, not just on local communities, but also on global economies and ecosystems. The Tambora disaster highlights the delicate balance between human activity, climate patterns, and geological events. It's a stark reminder that our planet is susceptible to sudden and drastic changes that can have long-lasting consequences. In 1902, Mount Pelée in Martinique unleashed its fury upon the nearby town of Saint-Pierre. This small coastal city was eerily quiet as ash and gas clouds gathered before the eruption. When it finally struck, a pyroclastic flow swept through the town at an estimated 100 mph, killing over 28,000 people, nearly every inhabitant of Saint-Pierre. This calamity brought attention to the dangers posed by volcanic ash. The fine particles released during eruptions can travel vast distances, causing respiratory problems and damage to crops. Ash has even been known to darken skies and disrupt global air traffic. One of the most striking examples of a climate-altering eruption is the 1810 Laki fissure in Iceland. Over several months, a massive release of sulfur dioxide changed atmospheric circulation patterns, leading to an extended little ice age that affected Europe for years to come. The scale and complexity of these events demand a more nuanced understanding of our planet's dynamics. We must recognize that volcanic eruptions are not just isolated disasters, but part of a larger, intricate system that connects the Earth's surface with its atmosphere. What can we learn from these catastrophes? How do they challenge our current approaches to disaster management and environmental monitoring? As we stand at the threshold of this new era of exploration and understanding, one thing becomes clear: volcanoes will continue to shape our world in ways both wondrous and terrifying.